Hello, sir. So we will be talking on Green Service Level Agreements Framework for Cloud Computing. Our team is comprised of Ankita Singh, Sujit Kumar Reddy, and Vatsalya Ahuja. This is Vatsalya Ahuja starting off, and we will be talking about so this is a crux of what all we'll be discussing here. We'll first start with the introduction, the features of the paper, literature and related work. Then we move on to the design, the existing design and what the proposed design is. Then we finally do analysis of the result and then the conclusions and the references.
Hello there. My name is Ankita Singh, and I'm going to be handling the starting few slides of this presentation. Um, as organizations are shifting their workload on cloud computing, the demand of cloud services has increased tremendously. With the increased usage of cloud data centers, there is a huge consumption of energy, contributing to high operational costs and carbon footprints to the environment. The deal is that so far research has been carried out to optimize energy usage for cloud resources. What hasn't been done is handling the service level agreement. And that's pretty much what this paper is going to be about. The methodologies applied so far for energy optimization are basically three. I mean, there are many, but we'll be talking about the most important three. The first one is virtual machines. The usage of virtual machines itself has many advantages, of course, because there's no physical infrastructure, but the placement, consolidation, and migration, all of this of virtual machines is what is done mostly. Through this, virtual machines are consolidated on a subset of servers and switching the rest of the servers into low power mode. So that's how virtual machines help in energy optimization. The second point, as you can see, is dynamic voltage frequency scaling. It's also called the DVFS technique. Energy minimization at the server and cluster level is what this handles basically. Now, how it works out is that the frequency of the CPU is adjusted according to the workload in order to optimize power consumption. So that is also another method that has been applied so far. And the third, as you can see, is thermal aware resource management. The goal of thermal aware scheduling is to reduce the data center wide thermal gradient, hotspots, and cooling magnitude. How it does this is by scheduling tasks while keeping in mind that the overall data center's temperature needs to be minimized. So, as you can see, these like are the basic methods that have been used for energy optimization. What this paper is going to handle is energy reduction at service level agreement level. What we know is that energy optimization at the SLA level has not been much emphasized in the past work, and this paper is going to focus on that. Cloud resources are provisioned with green SLA aware cloud resource reservation algorithm. This work proposes that the GSLA template and negotiation strategies for cloud services. It offers cloud resource services in an energy efficient manner to the users. So that's basically how this paper is different. Now let us answer a few basic questions. For who is this work going to be useful? What is the goal of this project and why this paper is special? So, for who is this? Small private cloud providers that have limited resources. As we know that the larger giants in this field like Amazon and Google provide a very big competition to such small private cloud providers, and it's very hard for them to make sure that they're efficiently performing in terms of work and at the same time care about the green aspect of the whole thing. So this format is going to help them do that. What is the goal of this project? It is to cater to the computational need of a large number of users by obviously small private cloud providers, which is going to be difficult when there are too many users, and it is to provide energy efficiency without severe loss in performance. Because obviously, if you try cutting down power or doing things like that, there might be a loss in performance. But such small private cloud providers need to be assured that there will be no such loss in performance, and they can also do eco friendly things while they're doing. Why this paper is special? Point one, GSLA architect has been framed that outlines the general negotiation structure and approach. Uh, Point two, a framework is implemented and tested for academic environment like universities, which counts as a small private cloud provider. Point three is that GSLA aware cloud resource reservation algorithm, which is the abbreviation I mentioned before, has been developed to provide resources energy efficiently. So these are the three main features of this paper that make it unique. Now we will get into the related works in this stream. As I mentioned before, there are very few methodologies that look into the SLA aspect of uh, um, making cloud computing green. So we're going to start with, there are two basic types. We're going to start with green SLAs. So yeah, the first one is green SLAs and the second one is renewable energy SLAs. There have been plenty of works in terms of green SLAs, and they can be seen as follows. This is one of the methods where each client specifies the minimum energy consumed for the submitted job. And of course, they'll be reprimanded if it's exceeding that. The second one is enhanced text based SLA by including semantic information regarding metrics and behavior. But the unfortunate thing is that users are not concerned with the specification of energy budget in advance. So that is obviously a perspective angle that needs to be changed, and it is happening slowly. These two guys, whose names I cannot pronounce, have focused on measuring and monitoring the eco-efficiency of green IT services offered by data centers. So basically, they involved an optimizer, which was the core element of the energy aware cloud framework, while also handling the SLA requirements and minimizing the energy consumption on federated cloud data centers. The fourth thing that has been done in terms of green SLAs is the particle swarm optimization. This is basically based on the negotiation aspect, wherein it evolves populations of possible negotiation offers for each party about a new offer, leading to an approximate negotiation solution. Another thing that has been tried is the Optimus Toolkit project, which has focused on optimizing the usage of cloud infrastructure services based on parameters such as trust, risk, eco-efficiency, and cost. So this is in short called the TREC parameters, and it's specified in the SLA. The trust model has an evaluation process at user level where the cloud providers are selected based on high levels of trustworthiness. So this becomes a pretty subjective method of going about things. Also, this is mostly suitable for critical business applications and more sensitive information, because that's mostly when people go for their gut feeling. A few more methods of green SLAs being implemented is the one mentioned here, where it was proposed that integrated power management would be a solution for virtualized data centers, which takes the benefit of virtual machine resizing and server consolidation for energy conservation and quality of service, as defined in the SLA. It has also been proposed that energy aware SLA or EASLA scheduling algorithm can be used for precedence constrained applications. What this algorithm basically does is it minimizes the energy consumption within the permissible limits of the make span of tasks. There's also the FIT4G, or the FIT4 Green, sorry, project has proposed an energy aware computing framework. It has basically comprised of energy saving strategies and planning. It's a pretty general this thing, which covers in a bunch of strategies that can be used for saving energy. We also have the plug for green framework, which is dealt with in technical SLA and energy related constraints through constraint programming. The proposed solution triggers two events: single allocation and global optimization. Now, this is what green SLAs have been proposing till now. But in this paper, higher inclination towards offering different energy efficient solution to the user. Users can see which offer is suitable for them, and energy aware virtual machine placement has been done using constraint programming that has been suggested. So this is the things that have been implemented in this project and shown in this paper. They have basically implemented it for a university, which is showing a small private data center, and basically users can choose which offer is suitable for them. Now we will go to the next one, which is renewable energy SLAs, and this also has a bunch of projects that have already been implemented. We'll start with this one. It basically discussed the notion of adaptive cloud hosting, where users have been given an opportunity to specify the renewable energy percentage for powering their services. And if this specification wasn't met, then the hosts would be reprimanded, and it would be some serious steps taken against them. Improving the energy efficiency of a data center through shifting the workloads to data centers having renewable energy resources. This is a nice way of promoting renewable energy resources. And yeah, the next one, as we can see, is um, renewable energy integration into data centers and analyzing its characterization using numerical models. So that was another model which was suggested to help renewable energy SLAs be established. The next is where it was provided as a solution for power or carbon constrained data centers that needed to scale out with large number of compute nodes. A power provisioning scheme oasis that could scale out data center economically and sustainably, and a multi-source driven power management scheme ozone has also been proposed. So these two, oasis and ozone together, helped work out this version of constrained data center. Now the next, okay, this also shows that the results of their study revealed that ozone could help Oasis to reduce workload execution delay by 1% and extend battery lifetime by 50%. So this was the entire project basically. Another method of doing it is by the usage of on-site distributed generation or DG sources. For this can be used for providing clean energy to computing load. In this work, a novel technique, namely power demand shaping, that is PDS, has been proposed that allows data centers to utilize on-site green energy efficiently. So, on-site distributed generation sources can apply this method. So, that's what has been discussed so far through SLAs, green SLAs, as well as renewable energy SLAs. But in our work, we are going to see these 3 points. The work discussed, it urges users to value renewable power computational hosts. It emphasizes on in I mean it emphasizes on the fact that we should incorporate renewable energy percentage into the system, and it also gives incentives to use more resources if they are powered by sustainable energy resources, which is all very it's not very difficult, and it is going to be very helpful for the environment, so it should be incorporated. Also, we see the following distinct features in the paper reviewed. It says that a balance between performance and energy conservation can be achieved through green SLA. A private cloud has been set up in university premises, which is used for academic workload. As I said, it is a smaller one compared to obviously Google and Amazon, and they have already implemented the project and seen that SLA level um, methods help in making green cloud computing work out. Also, to make resource usage policy eco-friendly, uh, that is another thing that they do.
Hello, sir. I'm Vatsalya Ahuja, and I would be covering the topics of existing design and proposed design according to the paper for green service level agreements. So, I would start with existing time. So, till now, what happens is the major focus has been on making the data centers greener. Instead, now the focus of this proposed paper is to make the interface between the user and the data center green. So the ways to the existing design, like we know, is to make data centers greener by reducing the PUE, minimizing the artificial cooling techniques, and using natural sources uh, like natural cooling, for example, in Oregon, which has a very good environment for data centers like Facebook and Google. The PUE that has the lowest that has been achieved has been around 1.06, and now this paper proposes a way so that we can now focus on the interface between the data center and the user to actually make that green too. So going to the next slide. um, yeah, so the green service level agreement. So in this diagram, you see there are phases like creation, negotiation, implementation, and the user that are involved in this GSLA. So we have a GSLA offer ID, username, GSLA energy minimization offer, SLA parameters, awards, penalties, and cost, and service terms. So this, in a crux, tells you what the service level agreement is about. It's basically on how to make the interface greener. So as you can see, the focus is now changed to this, and the methods, it consists of three major steps. One is creation. GSLA creation takes input details of user metric values for every SLA parameter, hardware, software, and time slot requirement. So creation basically involves of getting the data and then doing other things with it. So we go to the next step, which is negotiation. Negotiation offers deals with various time slots, cost, awards, penalties, service terms, energy optimization incentives, and alternative hardware configuration to users with requisite software. So since we, in during the creation, we have this, in negotiation we use the data that we've got in creation to actually propose a better way to handle things, better way to handle the interface, how to make sure it is further optimized, and we can save energy and make sure, like, as in the major aspect of green computing is efficient use of resources. So that is the major requirement that we're trying to fulfill here. Implementation. Often after negotiation, requests can be denied or resources can be reserved with time slot for user ID. So yeah, basically, since after negotiation, when the user agrees to the terms and the in creation, the data that you get, negotiation, you propose something, and then it is in their hands if they want to basically accept it or deny it, and then we go further with the plan. So now coming to the next topic, which is energy based resource provisioning policy, EBRPP, a negotiation approach. So this basically describes the negotiation approach. EBRPP has been designed on the basis of required resources, time slot, and energy consumption parameters, which is obvious since that is what we are getting during the creation. And any negotiation technique, it has to get data from the creation phase itself. So we are basing our negotiation on that. So when a user submits a request, resource manager checks the availability of resources. If available, a further negotiation is dialogued. In case of non-availability of resources, a possible time slot for resource availability is negotiated. The main objective of EBRPP is to provide the resources and minimize the energy consumption. So yeah, basically you check, in this negotiation technique, you check for the availability of resources. If it's available, you make a proposal. If it's not, you give them a time slot of when expected dates will be for getting the resources. And again, the whole purpose is to minimize energy consumption. Now coming to a case study where this paper has been applied a bit to check if it works. So this case study was done in the academic sphere. So to demonstrate effectiveness, the framework is implemented and tested for the academic environment. The framework uses a credit system. So a credit system is basically kind of a virtual currency that can change hands according to this system. The It can be exchanged with money in public commercial cloud system. Each student gets 100 credits in advance in his account on the start of the semester. Cloud instance credits are calculated based on offering resource sizes for user using large VM computational services. For 50 hour 5 credits are deducted. So basically this is a method by which we allocate credits and then deduct them on the basis of the usage and how efficient the usage has been. Credits add to students account based on failure to meet any specific part of GSLA and the unavailability percentage of the instance out of 167 hours on an average per month. So basically, depending on how efficiently you apply GSLA, this method deducts credits, and the credits that are left out with you can be exchanged for money. So basically, the whole purpose is to reward people who are using the cloud, using the interface more efficiently. So we come here to this slide which explains how the whole system is working. The teacher accesses the web portal. There is resource allocation queue, which then goes to the VM image repository, user accounting, host status, power consumption monitoring, which is again linked to physical machine 1, 2, and 3, user allocated free time slot, then the negotiation phase, then the policy decision. Negotiation phase is equal to EBRPP, then the green SLA, and accept then the student resource scholars can either accept or reject the implementation. So this diagram gives an overview of the whole proposed design that this paper talks about. And the performance evaluation. So the GSLA CRR algorithm is compared with the non-GSLA aware algorithm, and the results are quite good. On the user's request, if resources are available for the requested time slot, then it is allocated, otherwise a reject message is conveyed. So as you can see in this table, energy consumption parameters of physical machines. So these are the server types. For example, Dell PowerEdge R710 server has 3, the number is 3, the cores are 2 into 4, the model is Xeon E5620, the idle power in watts is 128.7, and the max is 247, and as follows for the others. So thank you, sir.
Hi, I'm Sujit. I'm going to cover the parts of results and conclusion of the paper. Here we start with the results. The paper presents a comparison chart of the proposed GSLA CRR and non-GSLA algorithms for which the virtual machines the number of accepted virtual machines requests to the number of virtual machines submitted. Okay. It also depicts the average power consumption of all the physical machines to the total number of virtual machines that are taken into consideration. Power consumption is of a physical machine is basically dependent on the number of virtual machines running, or the size of the virtual machine, the duration of the virtual machines, and the number of physical machines in the system. The analysis reveals the proposed algorithm performs much better in terms of power consumption to the scheduling when compared to the virtual machines. That is equal. Yeah, we are continuing with the results. In non-GSL algorithm, there is no specific ranking of servers, and the number of active servers were more all-time in comparison to the proposed algorithm. On receiving large number of virtual machine requests, the algorithm accepts more virtual machine requests because large size virtual machine requests are accommodated by high power efficient and large core servers. And uh, we also see the medium and small virtual machines are allotted to small core servers. With this implementation, the proposed algorithm is able to accommodate more number of virtual machines. Now, when compared to the same scenario in GSL algorithm, which is not proposed against the proposed, There is no ranking of servers and the order of virtual machine is specified. So medium and small virtual machines requests are allocated to large core servers, leading to their unavailability of the time when large virtual machines arrive. After scheduling, the proposed algorithm consumes more power but it accepts more requests. The proposed algorithm performs much better with respect to MEC on receiving a less number of virtual machine requests or having small virtual machine types also. As mentioned in the algorithm, servers are ranked with the ascending order of virtual CPUs. When a number of virtual machine requests are allowed lower, most of virtual requests are accommodated by high power efficient and large core servers. Remaining servers are in low power mode. The remaining, which are already allocated, the remaining. Secondly, through the negotiation, all the virtual machine request reservations are aggregated into as one part of slot from being free time slot, or it's switching off the resources into another part which is another time slot. uh, Thus the paper tries to prove that the proposed algorithm it consumes more power even though as it is going to give better results by creating more virtual machines. The conclusion of the paper: in this paper, the green SLA management and an EBRPP have been discussed for a small cloud, which is IaaS cloud. They aim to minimize the energy consumption of the data center. Green SLA deserves the provision of resources that negotiation with the user. The proposed algorithm leverages a free timetable slots and free weekend days. Also, they are used and adjust user request in the time slots and negotiation to enhance the acceptance rate of the power. This work has also evaluated the proposed work with a non-GSLA aware. The results show that the GSLR significantly improves the acceptance rate of energy consumption by the negotiation. In the future, more completed work cases will be analyzed, and the paper future scope of the paper is said in this point. In the future, more completed workload will be analyzed, making the approach generalization for better power consumption. Thanks.